Welcome to Cracking the Codec. It's all about the implementation. A few months ago, Jan Ozer wrote a provocative article that asserted that there are no codec comparisons, there are only codec implementation comparisons. We thought that was a topic worth digging into a little deeper, and so we asked Jan to join Norsk CEO and co-founder Adrian Rowe in talking about that in a little bit more detail, talking about codec implementations, codec settings, codec parameters, and how those affect the decisions you make to be able to deliver the best quality content to your viewers at the lowest bit rates possible, while also taking into consideration price. So we'll talk about all of those things. Jan and Adrian will go into considerable detail. Before I hand things over to Adrian, though, if you have any questions for Jan and Adrian, please enter them in the Q&A tab at the bottom of your Zoom window. Towards the end of the webinar, we will take a look at the Q&A tab, see what's come in, and pose those. I will pose those questions to Jan and Adrian. You do have the ability to upvote questions, so we'll decide which questions to use based on how many votes particular questions get. One other note, please do not answer questions for other attendees by typing the answers in the Q&A tab. That has a tendency to take them off the board, so to speak, so that Jan and Adrian and I can't see them. Also, closed captioning should be turned on by default. If you find that distracting, you can go to the hide captions button at the bottom of your screen and turn those captions off. And finally, at the end of the webinar, some of you, thank you very much, filled out a survey we sent out ahead of time, and we will be announcing the winner of a $50 Amazon gift card, randomly chosen person who filled out that survey. And speaking of survey, we're going to kick things off with Adrian Rowe, who will talk a little bit about the results of that survey and set the stage for what's to come the rest of this hour. Welcome, Adrian.
Thank you ever so much, Eric. Absolutely fantastic to be here. Really excited about the topic. So I'm just going to set the scene and then basically hand over to Jan and bask in the reflected glory, because really excited to be here with such a kind of authoritative figure in the codec world. And before that, though, there's no such thing as a free lunch. I want to talk a little bit about what we do in the context of why I think this is such an important topic. And in particular, I'm not going to talk about our product or about what it does or anything like that. I am going to talk a tiny bit about why it does it, and why we're so passionate about this particular subject. And so Norsk is all about removing technical complexity from live media workflows, and in order to be able to get out of the way, in order to be able to allow people to focus about the creativity and to iterate really rapidly. And we do that in kind of two different products. We've got a whole no-code solution which allows you to drag. Here we've got a bunch of cameras coming in over SRT, and we're choosing and mixing those cameras together, and we're adding overlays and logos and SCSI markers and publishing and so on and so forth. And that's the kind of thing that with Norsk you can build in minutes. But the why of all of that is an invitation to be ambitious and to ask people to focus on user experience, not on media technology. Despite being passionate about media technology ourselves, the important part is the UX, and the technology is an enabler, but not a differentiator. So yeah, that's it. That's an end of sales pitch. What's our journey? What's Ideas or Norsk's journey with codec implementations? Why did this topic resonate quite so much? Well, over the years we have integrated with 8 different H.264 implementations. I think 6 or 7 of those are still kind of active in the latest version of the product. 5 HEVCs, 3 AV1 codecs, and there's a whole bunch of others. There must be another 6 or 7 less well-known codecs out there. And I think that entirely reasonably begs the question: what on earth were we thinking? H.264 is H.264. Surely. And then what was really exciting was, 2-3 months ago, Jan posted what you can see hopefully on the right-hand side there on LinkedIn, and it was kind of, yes, that's why we don't think we're completely mad, that, and in particular, why is it so important? We think that our kind of whole philosophy is that choice of codec is a business decision. Further, choice of codec implementation is a business decision. And both of those choices can make a really, really big difference. And hopefully that's something we can start to explore a little bit more in detail once Jan has kind of added the sort of substance to the session. So very, very quick summary of some of the highlights from the survey beforehand. A couple of things I should say. One, this is not a statistically significant survey, but I do still find it interesting. It also doesn't reflect the market. It reflects the audience sat here today in the seminar. And strange enough, big focus on live event streaming. What is it that people are delivering? A little bit of SVOD and AVOD, fast because that's on the up and up and up. And then of that live event streaming, a minority is corporate based, and we have experience both in kind of sports and corporate and so on. Codecs, strangely enough, H.264, it's the big granddaddy still, it's the dominant one. HEVC, and I think this does reflect what's happening in the market, is, there are rumors that they're starting to work out the sort of patent pool type stuff around HEVC, and then people aren't quite so sure, and then they are again, and then they aren't, which is all slightly exciting. AV1 is obviously starting to get some penetration. I personally was slightly surprised to see the presence of VVC. I'm really excited that that's starting to hit production usage. I think a couple of other trends that are increasingly important is that high-end bit rates are starting and resolutions are starting to become more and more prevalent. So again, I was surprised that top-end resolutions, nearly half of them were 4K. The fact that it doesn't add up to 100 here makes sense because some people had multiple ladders, and so some of them would have had 1080p as the top and others 4K, etc. But still, definitely a move towards higher and higher qualities as we go on, and with that, higher and higher bit rates. And again, higher and higher minimum bit rates is also something that I think is starting to get quite interesting. The top end bit rates are really, sort of 8, 10 meg and above, but the low end bit rates and the low end qualities are also starting to go up and up and up. So thank you very much, all those who replied to the survey. Really interesting. Hopefully we can use that to make this discussion more relevant to the specific audience's context and use cases. But now let's go to the meat and potatoes, and I'll invite Jan to step up. Thank you very much.
Thanks, Adrian. Thanks, Eric, and thanks y'all for joining us. Let me bring up my presentation. So everyone should be able to see my presentation now.
Yep.
And you can download the presentation at this bit.ly URL. It's Google Docs. It should work. It never seems to work. If you have to send me an email to get it, that's fine. By way of background, I was giving a presentation in Serbia in October, and one of the topics I wanted to cover was how AV1 compared to HEVC in terms of encoding efficiency. And I started looking at different codec comparisons, and we'll see the ones I looked at in a moment. And I noticed that there wasn't a single number. It really depends a lot in terms of which study you look at and how that study was performed. And there's a particularly significant difference between live and VOD. And a lot of people say, yeah, well, AV1 is 50% more efficient than H.264 and 20 or 25% more efficient than HEVC. And usually they have some study that backs that up, but you don't really care about what some study says. You care about what your codec does and what your product needs and your project needs require your codec to do, and then how that codec compares to that. So a lot of people say, why aren't a lot of people switching to AV1 for live? Well, the answer is a lot of the live encoders just aren't really performing that much better than HEVC at this point, even though with software, you can get 50% better efficiency with AV1 than you can with HEVC, and certainly more for H.264. If you look at the transcoding hardware, and we'll look at some examples in a moment, the numbers are much closer. And if the numbers are closer, meaning the advantage of AV1 isn't as great as what you think it is, then the cost of switching becomes much higher. And anyway, the genesis was I wanted to benchmark AV1, and then I discovered I couldn't because it really did vary by implementation. So that's how we got to the title. I kind of just covered what the initial topic was, the myth of the codec comparison. And then I want to, quality is something that we almost take for granted. I think we assume that a lot of the technologies deliver the same quality, and they really don't. And the cost of quality is bandwidth. If you're getting a product that doesn't supply the same quality as another product, you have to boost the bandwidth to equal, whether it's VMAF 95 or whatever target you set. If your quality isn't as good with the encoder you're using, you have to boost the bit rate, which means if you buy a lower quality product, you pay in terms of bandwidth during the useful life of that product for the next 5 years. So, you don't lower the quality because you're using a product that doesn't deliver lower, better quality. You're increasing the bandwidth. So I just wanted to make that point, and we'll look at some numbers that back that up. And then we'll look at some brief implementation costs. It's not, assuming you can get the quality either equivalent or you understand how much bandwidth it's going to cost you going forward, you need to look at what it's going to cost to implement. And that's a pretty interesting exercise. And I recently put some numbers together for an article I was writing for Streaming Media. It's in the source book. It'll come out in April. And I want to show you what the implementation numbers look like for both cloud and on-premises, and with pretty detailed examples. And there's a Google sheet you can download at the end of this that'll give you the ability to run the same numbers that I did, run them with the transcoders that you're testing and their particular parameters. But I wanted to go through the analysis so you understand what's in the sheet. So here are the 3 codec studies I talked about. One was kind of an academic study, performance comparison of VVC, AV1, HEVC, and AVC at high resolutions. The next was the MSU, that's Moscow State University, video codec comparisons. This is a software comparison. And then the third one was the hardware comparison. And this is an overview of the test parameters. And it's basically a lot of the different configuration options and a lot of the decisions that the individual test producers have to go through when they decide how they're going to test. And this is gruesomely boring stuff. But if you don't understand what you're doing and you don't really peg down each one of these, and in fact, it's a lot more. It's thread count, it's GOP size, it's it's almost endless. But these are the basic parameters that I pulled from the studies, and we go through the codecs that they covered, and here the developers, they looked at the FFmpeg codecs. They looked at X.264, X.265, and SVT-AV1. And that's kind of interesting. I mean, because a lot of people use those particular codecs for the distribution that they're doing. On the other hand, the MSU software went into a lot of third-party codecs. So I think they looked at main concept. I think they looked at Tencent. They looked at a lot of other compression technologies that are available that were a lot more efficient than what you get with FFmpeg. So, FFmpeg isn't the only thing. It may be the only thing for a lot of developers, but if you're a high volume streaming shop, then higher quality codecs, even if you have to pay a royalty for them, are going to deliver a better overall cost benefit on the bandwidth side. And then MSU was, the hardware here was just hardware, so there wasn't a lot of commonality between the first two. And then you look at the number of passes that were pursued. The academic was 2 pass. It was single pass for software and single pass for hardware. Obviously, looking at some things that are a little bit more low level. The researchers here, they used average bit rate. What's the problem with average bit rate? Nobody uses it. Everybody either uses VBR or CBR. And Same thing with the MSU software and a lot of the different comparisons they ran. They used CQ encoding. CQ is really good when you want to benchmark how, the theoretical performance of a codec, but nobody uses CQ in production, so you can't really generalize the results you get with CQ-based encoding to VBR or CBR. Rate control is one of the critical aspects of an encoder that's separate from the codec that's actually in that encoder. And then for hardware, MSU used CBR as well. Presets is another huge differential. The researchers here, they went with the medium preset. I don't recommend using the medium preset. You'll see why in a few minutes. MSU focused on different use cases, 1 frame per second, 5 frames per second, and 30 frames per second. So they used presets that allowed them to achieve those performance targets. And then they did the same thing with hardware here. The quality metrics were similar for all of them. MSU a little bit more sophisticated. They used VMAF negative to see if anybody was doing any spoofing. Test sequences, these guys use 7 that range from 8K to 1080p. MSU uses 50 that were all 1080p. That was the focus of their study. The survey that Adrian showed, there were a lot of people doing 4K, so you'd want to study that incorporated that codec performance at 4K. You really start to see the benefits of some of the higher quality codecs, HEVC and AV1, as compared to H.264 once you go beyond 1080p. So, what are the red flags? The bitrate control I kind of I covered, the presets I covered. The command string, I typically recommend using a simple command string because I think you can get yourself into trouble. There's a lot of opinions about what really moves the needle in terms of quality. I find unless you do the testing and confirm that there's a qualitative benefit, I basically just go with very simple settings, get the GOP size right, get the bitrate control, pick the preset that I want to use. Thread count is pretty important for quality reasons, but beyond that, I typically don't do a lot of adjusting. MSU talked to the vendors to get their feel for what the command string should be, and that's what they did. And then tuning is a tough one. Tuning for metrics is just challenging. If you're trying to find the encoder for internal use, there's no right answer for tuning. These guys didn't do it. MSU did do it. MSU is correct because they were presenting their results using video quality metrics. But you don't use tuning when you do your own testing, or typically you don't. So it's a tough issue here. So there really is no perfect answer. You look at the summary of AV1 performance. What was interesting was that MSU does a nice job and they benchmark everything against X.265. So basically they adjust the quality scores so that X.265 using I think it's the very slow preset is 100%, and then they go how much additional bandwidth do you need to use to equal that quality with these other codecs. So what we see here in the academic study was X.264 was 70% less efficient than X.265. You get the same quality with AV1 with a 25% reduction in bit rate, and the same quality with VVC with the 53% reduction in bit rate. So VVC was the winner here. We see a 25% advantage for AV1 here. MSU software, they found X.264 much less efficient than X.265. And the most efficient AV1 implementation was, delivered 63% benefit as compared to X.265. So, I mean, that's a pretty compelling number. And then if you look at the hardware, the best HEVC implementation was 15% more efficient than AV1. Let me verify that number. So here's X.265, and this is the hardware. Most efficient H.265 was 74% of that number, and the most efficient AV1 was 90% of that number. So in the hardware study, it looks like the HEVC was actually more efficient than AV1. So, why aren't there a lot of services using AV1 for live? We have a lot of hardware devices that now support it. We've got, NVIDIA supports it, AMD supports it, Intel supports it. AMD with the MA35D does, NetEnt supports it as well, but the numbers just aren't as compelling for AV1 transcoding for hardware as they are with software where you don't have to worry about throughput. What's the point here? We know all this stuff, and basically the point is, unless the study really closely matches how you're going to deploy the product and covers the products that you're considering, it's not really going to be useful for your analysis. You're going to have to do your own work. And in particular, getting back to the point that Adrian made, and that was the focus of this topic, there are no codec comparisons. There's just implementation comparisons. How much does quality matter? This is, this is the structure we did for the streaming media article that I referred to a moment ago. We assumed a 100 channel fast service that had, multiple rungs, and then we computed the average bit rate for, for the different channels and what that translated to in terms of costs, and it turned out to be about $740,000 for a 5-year period. And then we looked at the MSU hardware quality study, and these are a little bit more the details of the boards that were in there. And then we say, okay, if you use the NVIDIA, which delivered, in this case, H.265 at 99% of the reference X.265 encode, or you use the Intel Arc, which delivered the same quality at 80.8, there's a 23% difference. So you have to boost the bit rate from this 80.8 by 23% to get to this number here, which means that the difference in quality is going to cost you $170,000 over the 5-year life of those channels. And then you're looking even bigger. If we go from the 80.8 here to the AMD, their graphic, not their MA35D, but their graphics card transcoding, then we see a 78% boost in bit rate, which means $578,000 in boosted bandwidth costs over the 5-year life of the product. So the cost of quality is bandwidth cost, and I just wanted to make that point. I think this stuff is pretty obvious. I did a lot of work as it related to choosing the right preset. I want to use, I think it's an interesting way to look at it, because you wonder, how much quality costs you in terms of bandwidth is going to depend on a couple of things. Is, how much do you have to boost the bit rate by? We covered that. And also, how many viewers do you have, and what does that translate to in terms of cost? So the same analysis, whether you choose a high quality encoder or high quality preset, it's kind of similar. If you choose the ultra fast preset, you're going to get a very low transcoding cost, but you're going to have a high bandwidth cost because you have to boost the bit rate to equal the quality of, say, the very slow preset. And then the inverse is true for the very slow preset. You have a very high transcoding cost, but you have a very low bandwidth cost. So this is an analysis I did for the H.264 preset. And basically what I looked at here was, this is the encoding time. And I kind of ignored placebo because nobody ever uses placebo because it doesn't deliver any better quality than very slow, and it takes 4 times longer. So this number here tracks the encoding cost, and this number here tracks how much you have to boost the bit rate to equal the quality of the very slow preset with this preset. So in this particular case, the ultra-fast preset saves you 94% of encoding costs if you're paying for encoding costs yourself, like renting an AWS instance, but you have to boost the bit rate by close to 200% to equal the quality you get with ultra fast. I'm sorry, to get the quality you equal with very slow. And then here's, this is just a quick calculation. I'll only look at this one. This is at 8 cents per gigabyte. So how many viewers does it take to make up that cost for the different presets? That's what we're computing here. This is the bit rate. This is an H.264 comparison. So I assume 4 megabits per second for 1080p. That's fine for primetime stuff, probably not good for sports. This is what it translates to in terms of gigabytes per hour. This is the encoding cost per hour based upon some other studies I did using AWS. And then what we looked at, and this is cost per gigabyte, I mentioned that a moment ago. This is the encoding cost, where the very slow is kind of the 62 here, that's the 100%. And then ultra fast is the 95% reduction on that. Placebo is the 4x gross up of that. And what we did was we looked at the encode cost here, we looked at the bandwidth cost here, and this is the cost of the bandwidth. And then we basically rolled this out over 50 hours of watching, 100 hours of watching, 250. And this is just basically proving the numbers here. So the encoding cost, if we do faster, the encoding cost is 12. The if you look at 250 times 0.18 bandwidth cost, it equals 45, and that's how you get the number here. Bottom line is, even at 50 hours of video, the very slow preset, even though it costs 95% more, is going to be the better alternative than than the ultra fast preset. So then, even at 50 hours, which is the lowest number that I checked, it's better to spend the money on encoding and get higher quality than it is to save encoding costs and then pay additional bandwidth costs. And the numbers change a little bit, as you go down to 4 cents per gigabyte. The bandwidth savings are a little bit less, which means encoding costs become a little bit more important. But still, even at 100 hours of watching, this is the lowest. And then even at 2 cents, it's 250 hours of watching. So if you cut the bandwidth cost by, 75%, it changes things a little bit. But if you're at 250 hours of watching that video, it makes sense to use the very slow preset. And that the analogy again goes back to how much does it cost? The analogy goes back to, how much should you spend to get the best quality encoder? And a lot of that relates to, both the bandwidth cost and the number of videos that or the hours that people are watching your videos. If you're a very, very high bandwidth shop, way bigger than the 5,000 hours per video, then you should spend a lot of money to get the absolute best quality, because you're going to be able to really reduce the bandwidth cost to a significant degree. And any additional cost of the encoder is going to be more than made up for in terms of overall bandwidth savings. Kind of summarizing what we've been to, there is no one size fits all codec comparison. We covered that, and the cost of quality is bandwidth, and it really pays to get the best possible quality that you can. And then looking at deployment costs, here's the Google sheet that I told you about. You should be able to access that now. And then these are, I just want to walk you through the analyses. They're pretty dense, but this is what you have to do to kind of figure out what your, quality is one thing, and you know how to compute that at this point. The other thing is, what's it going to cost to implement this? And it's really kind of interesting. Here we're looking at two basic approaches. One is the AMD U30, and then the other is the NVIDIA T4, and they come in different instances, and the different instances have different throughputs, and the different throughputs mean that you have to get a certain number of those instances and keep them running to support the 100 channels that we use for computational purposes. So this is the instant type, this is the instant cost, this is the throughput that instant delivers. This is the units that you need, meaning how many do I need to support the channels that the 100 channel fast service was producing. And it turned out that the overall most efficient was the G4DN extra large. The important thing isn't the fact that it was the most efficient, it's how much different the cost is if you use one that isn't efficient. Why this analysis is so interesting is because there really was a huge difference in cost. And we're going to see with the hardware analysis on premises, we didn't see quite as big a difference. But if you choose the wrong instance, if you choose the more expensive T4 based instance because you think it's going to deliver a lot greater throughput, then you're gonna end up spending a whole lot more. When you're looking at instances, obviously you want to look at quality. That's kind of what we covered, but you also need to do your benchmarking to determine the throughput per instance, and that's a pretty straightforward type analysis. And this is what it looks like for codec deployment if you're doing it on premise. And when I say on premise, I meant typically, colo, because colocation costs were the easiest to estimate in terms of coming up with the comparative costs. But here we looked at the MA35D, which is and let me go back to here. The MA35D, which is the AMD card, is not deployed in any, I guess it's deployed in Azure, but it's not in AWS. And the NetInt card is now in Akamai in beta, but it's not in any of the major cloud transcoding or cloud ecosystems. So that's why I didn't look at those particular cards. The only two that AWS carries today are the AMD U30, which is a FPGA-based transcoder, and then the NVIDIA T4. They may have some additional NVIDIA T4s. The throughput numbers here were from a Wowza study and I cite that in the article that you'll see in April. So, and then, if you're looking at the on-prem cost, pretty much the same analysis. You need to figure out what the throughput is for that particular device. You've got to figure out the maximum number of devices you can put in a server. You got to figure out the cost of that server, and then how many servers you have to buy given the throughput that I just discussed. And what's interesting about this analysis, you go through the total capex, how many servers do I need to buy with the cards in it, and again, the numbers here are not quite, they're very, very similar, no major difference there, but the Quadra, because it's an M2 based system, can fit in a 1RU rack. The MA35D needs a 2RU, and the T4 needs a 4RU, which really boosts the co-location cost significantly. The T4, you need 2 of these, and they're GPUs. They're not ASICs, so they use more power. Bottom line is, there's very little difference between the MA35D and the Quadra in terms of overall capex and opex over the 5-year period. The T4 is a lot more expensive because it's a bigger, you've got to have more servers. The servers are bigger and they use more power. So there's no quality comparisons that I'm aware of between the MA35D and the Quadra. So we can't really cite the quality at this point. Hopefully that's something we'll be able to put together once both of the cards are available in a public cloud so that we can test them the way we want to test them. So, bottom line is choosing the best transcoder is very challenging. It's I've done a lot of codec studies and every one of them is a nightmare, but the qualitative differences between the products really do translate to significant bandwidth costs if you're in even a medium-sized system and beyond. So you really need to do the work to arrive at a quality comparison that you think is relevant to how you're going to be using the product. And then once you figure out, assuming there's two boards or 2 instances that are close to each other in terms of quality, then you need to run the analyses to figure out what it's going to cost you. And that's where the spreadsheet that we linked to a moment ago should be helpful. And that's it. Eric, I guess it's back to you.
Thank you very much, Jan. Great stuff there, and looking forward to seeing the rest of it in the streaming media article that will be coming out in April, you said?
Yes.
Excellent. We've got some audience questions coming in, which is great. Please put your questions in the Q&A tab. Jan, we seem to have lost your video, but all indications say you're still there. We go. But I've got a couple of broader questions to start with. And working for a British company, one of the favorite phrases that I've learned is horses for courses, right? That essentially it depends. And so we know that every scenario is different and you need to look at your particular application. That was, a central conclusion and point that you made, Jan. But in each case, there are maybe 7 or 8 considerations that you're going to have. Adrian, can you start going through those, and then Jan, chime in where appropriate? What are the considerations that no matter what your use case, you should be looking at?
Sure thing. To be honest, I think we come at it from a sort of slightly different angle. And what's one of the things I love about the work Jan does is a bunch of sort of science and hard numbers against it, whereas we come from the sort of practitioner end of things. And so your consideration number 1, frankly, is availability. What choices are open to you? Are you on-prem? Are you in the cloud? In the cloud, will the availabilities of things like NVIDIA instances meet your peak requirements? That's something that has caused headaches for some of our customers in the past, where it's all very well saying to Amazon, I'd like another 50 NVIDIA servers, but if they don't have them, that starts to become more challenging. Obviously, Jan talked an awful lot about efficiency. Again, the amount of bit rate that you need to drive a particular quality. I think that's a 2-edged sword, because I think there's a lot of people go, if I'm currently delivering 1080p at 8 meg and I can start delivering it instead at 5 meg, I'm going to save whatever the percentage is between those 2 things. And I think in reality that is very seldom the case, because consumers behave in a way where they consume up to a bandwidth far more than they consume up to a quality. And what happens is if you move to a higher quality codec, actually what often happens is consumers they get a better experience, but you don't necessarily realize bandwidth savings because they're now consuming 4K instead, because you've moved your AV1 to 4K and your 4K to AV1 and so on. And so it's not only measure, but measure in your context, and also understand a little bit about how your audience is likely to respond, because just having higher efficiency, lower bit rates for any one of the rungs doesn't necessarily mean that your CDM bill is going to go down in the same proportion. It almost certainly will go down, but it may not go down by the same proportion. And the ones that really matter are the top and the bottom. At the top, you can't go above your top rung, so that is going to have an impact. And the bottom rung, if I can deliver a better quality at the same bit rate for the bottom rung, then I'm going to be giving a better experience to my consumers. What happens in the middle is a little bit less obvious. Again, other things that I think we would certainly ask people to consider, not least because it has commercial implications, is energy usage alongside that density. There's a number of solutions that are that give extreme density, and things like the Quadra and the MA35D and the NetInts and so on. Energy is an important part, and I think as this industry matures, it's something that I would like to see come more and more to the fore. Couple of others just while with here, degree of compatibility. I think this used to be a big concern maybe 8 or so years ago. One of our customers, we helped take them from a solution that was working on 16% of target devices, and we ended up getting it working on 96% of target devices. And that was, initially they were on an H.264 codec. They ended up on an H.264 codec, but we managed to tune exactly how we constructed that in a way that made it significantly easier to consume for their target devices, which were fairly old. I think that's slightly less the case now, but still, especially if you're targeting older devices, compatibility can be a challenge. And then latency, different servers, different codec implementations give quite different latency requirements. So if ultra low latency is important to you, then again, that's going to impact some of the choices you make.
Jan, do you have anything to add to the list of considerations Adrian just rattled off?
Yeah, in America we say the best ability is availability. So I would agree with Adrian. Now, I mean, I covered the things I think are important. I will say that changing codecs is a little bit different than changing encoders. Changing codecs, you really have to go through what's my encoding ladder look like for HEVC versus what it looks like for H.264. With transcoders, I think you can assume, well, the same ladder is going to be about the same. It's just really a question of, what's my top bandwidth going to look like to achieve the quality that I'm targeting. And then Adrian's right on point. I mean, when you're looking at changing codecs in particular, the only rung you're going to save money on is the top rung. Everything else is going to be an improvement in QoE. So most of the time, if you're changing codecs, there's going to be some savings. Particularly if your current customers are mostly retrieving and playing the top rung. But if you're serving a mobile audience and they're in the middle rungs, you're going to get almost no savings, and you're going to get hopefully a noticeable difference in quality of experience.
Yeah, and one of our attendees posted a comment saying, glad Adrian brought up the bottom rung. Serving decent looking video to that bottom 2% of your audience on crappy connections is really important and often neglected. So you've got to look at the entire rung to make these decisions. Adrian, can you give a concrete example? I think you touched on it a little bit already, of when a codec implementation made a real difference for customers or end users. And Jan, then please follow up as well.
So we did a project with Archiva a few years back, precisely targeting hybrid TV services, where you're delivering the presence of a channel over the air, but you're actually delivering the content of the channel OTT. And there, it wasn't even just a case of changing presets or tuning stuff like that. It was right down to the kinds of detail that live 2 or 3 layers down. And I think that's one of the big challenges that you have in the codec world is, with something like Norsk, you've got a choice of 8 different codec H.264 implementations. Each of those H.264 implementations probably has of the order of 100 bells and whistles that you can tweak. And so, absolutely going to here's a preset that's going to take me 95% of the way to where I want to get is a good place to start. But in extremes, that can actually going down to the next layer of detail below can be useful. And so again, we want to try and make that a business opportunity as opposed to, oh, I've got to completely change my tech stack in order to deliver this. I think again, the other thing that's interesting in terms of where it makes a difference is depends on your load profile. I think some of the hardware that Jan mentioned is starting to become particularly interesting, especially on-prem, where I can now start to do maybe 50 1080p's in 1U, or maybe even more. Being able to meet that kind of load on-prem starts to, what would have taken 2 or 3 racks of equipment just a few years ago, you can now do in a few U, which is amazing. That model doesn't go quite as well into the cloud, perhaps as it might, not least if you're looking to cover that for occasional use, where I don't need, I need one, I've got 12 events running, and now I've got 15, now I've got 10, now I've got 50, because on a high-end NVIDIA instance or a high-end NetInt instance, suddenly by adding one server, I'm adding the capacity for another 50 channels or something. And so again, you need to look at the business model and the costs in terms of your load profile, because if by going up by 1, I suddenly have to add up an extra 50's worth of capacity, or maybe I've got a server running 50 channels and then 30 of them disappear, how do I get that channel onto something cheaper, and so on. So again, we're practitioners. The devil is in the detail, and you need to model your use case and your load very carefully.
Jan, how about you? Can you talk about any concrete experiences that you've had or examples that you've had where you've seen this codec implementation choices make a big difference?
I've seen more ladder changes. I think some of the services that I work with were, they started off very conservative, and they said, well, we're going to use 8 megabits per second for our 1080p streams, irrespective of what the show is. And we did some work where we looked at, using the VMAF 95 target, we saw that for 95 to 99% of their shows, they could achieve that quality at 5 megabits per second, certainly for most of their primetime non-sports type programming. And they made the change down to 5 megabit per second cap for a lot of their primetime content, and nobody, there was no response from the viewer base. So that was that's a pretty significant savings at really no cost other than some consulting fees. So that's probably the best.
Okay. What about audience size? Jan, can you talk a little bit about how audience size might impact your choice of codec implementation and your settings?
Yeah, audience size is huge, and I think we saw that in some of the examples that I showed. Even at 50 hours of video watched, we saw one price. Once the number of viewers multiplies the bandwidth cost, and as the bandwidth cost gets bigger, the encoding cost gets proportionately smaller in terms of a portion of the overall cost of producing the event. So, I mean, if you're, we looked at this at NetInt, quite frequently. If you're doing a gambling scenario and you've got 8 or 10 people watching your video, you can afford to encode it pretty low quality at a high bit rate because there's only 10 viewers. On the other hand, if you're doing the Super Bowl, you've got 50 million viewers, you want to make that stream as tiny as you possibly can, because you're paying to distribute it to every one of the viewers.
Adrian, anything to add to that?
No, I completely agree. It's the I think there's every now and then I kind of think actually maybe what we should just do is go agree as an industry that good enough is good enough, and go get on with other elements of the detail. But the reality is not like that. I think there are also the way CDNs charge isn't necessarily directly related to their internal costs and so on. So actually, as capacity goes up, that doesn't necessarily, the higher load goes up, the bigger their margin gets, for kind of obvious reasons. And so, Jan's exactly right. For if you've got large audiences, then if you can bring your average bit rate down, then that's likely to be the dominant factor. If you've got smaller audiences and you're looking to deliver a premium experience, then that's going to be your decider.
Speaking of good enough, we have an audience question that talks about a different kind of good enough. Are we reaching a point where compression is good enough, quote unquote, and balance that with more bandwidth availability, the choice of codec becomes almost irrelevant?
Yes. Yes and no, and I think there's some really interesting work being done in this area. So Yuri, for example, Yuri Resnick did some very interesting work where they're looking at number of rungs in a ladder and what that does to consumer experience. And they were, there's some primary evidence that says, actually, if I've got lots and lots of rungs in my ladder, then what I get is lots of not particularly perceptible changes in quality as my local network conditions vary. But each change in up and down the ladder rungs takes you out of the viewing experience. You notice a change in quality. And so actually you're delivering a better user experience with a ladder with fewer rungs in it, because while the VMAF score may not be as good, what you're not doing is you're not changing between different VMAF scores regularly, and it's the change in quality that people notice far more than the absolute in quality and so on. So I think it's one of these things where, as an industry, bigger is better, and if I'm doing, it's very hard and to not market services to consumers based on these bigger and bigger and bigger numbers. But actually, the reality is sometimes in doing that, you're not necessarily improving their user experience. So I think that's especially true at the very, very high end, where the number of people who can actually tell the difference is increasingly small.
I think that's it really comes back to how many viewers you're streaming to. I mean, I think 90. I'm kind of running the numbers in my head for another sourcebook article, but I think that for 99% of websites that are streaming out there, it doesn't matter, because you're not streaming enough. If your bandwidth costs are a couple $1,000s a month, and you don't care. On the other hand, once why do you think Netflix and YouTube and Meta are most aggressive with AV1? Because they're spending gazillions in bandwidth costs, and if they cut that by a small percentage, it's a huge number. So it's a different issue than the one that Adrian was talking about. But I would agree that for, I don't even know what the number is. It could be the top 500 websites out there really need to care about it, and everybody else can just use H.264 to their heart's content, because it's never going to make that much difference.
Jan, we have a question regarding your 100 channel fast service model. Did you model that example based on the live encoding of 100 channels, or encoding all the content offline VOD style and then delivering?
It was live.
Okay. All right. Good to know. And you also brought up net-in cards, and you mentioned AMD cards, the MA35D in your presentation. Could you talk a little bit more about the impacts of those when those cards become a reasonable choice for publishers to be looking at, et cetera, et cetera?
The analogy, we just talked about the 500 websites that care. So, if we look at those websites, and then, obviously we look at live, which is, a big percentage, but it's not a dominant percentage, and all those technologies are live. So I think they're going to have a nice impact in terms of, in terms of media and entertainment, I think where they're going to make their bread and butter down the line is going to be, security and surveillance and some of the, maybe some of these machine-based applications. I think there's just too few websites that matter from a media and entertainment standpoint. And it's going to be a lot more on the production video that's outside those markets. So, and there, I think that's where they'll, they have a very, very significant impact on the market as a whole.
I think there's, if I had a magic wand, I think I would wave it in order to generate more competition. I think the presence of ASICs in the market looking to change density, looking to bring hitherto fairly exotic codecs, AV1 and so on, to the masses, and doing that at a frankly reasonably impressive price point is really important. I think there are, even in something like an NVIDIA world, you have some choice of codec. You've got NVEnc and those kinds of codecs that'll build on that, but there's a ecosystem built around those kinds of companies like Beamer and so on, who will then do their variant of encoding on top of that, and they can bring maybe CABR and AI type capabilities to the table there to try and give better live coding experiences. So I think there's it's a little bit swings and roundabouts. What I do fear is that as an IT industry more than a media industry, the whole rush to, if it's not AI, why the hell are you doing it, is going to be bad for competition. I think it's so tempting to go, well, if I invest X hundred million to develop this piece of silicon, or I develop why would I do that anywhere other than AI? Because if it's AI, what's happened this week notwithstanding, that's going to really impact my bottom line. So I'm super excited about the kind of work that NetInt and AMD and so on are doing in the space, but I do worry for the long-term health of the industry, because I think the giants need to be spending more time on media than they are doing.
Yeah, the problem is the total addressable market. I mean, the cost to develop a chip like the Quadro or what the MA35D, if it makes total sense for Google to develop their own chips and Meta to develop their own chips, because they're just, their demand is overwhelming any way you measure it. But the rest of the market, it costs a ton to develop a chip, and then the total annual expenditures on encoding products, I'm not sure that in the media and entertainment market alone is going to be sufficient to support that type of investment. So it's going to be interesting to see. I think there are natural markets that they need to pursue, that are going to be very, very viable. Some of them are going to be the whole autonomous machine. Some of them are going to be the security that I talked about before. There's a couple of others, but media entertainment is a challenging market. It's just not that big. It's not 5 years ago or 10 years ago when it really was in the growing phase. It was wild, wild west. But at this point, it's a pretty mature market. It's not growing. People don't need that number of transcoders. They don't deliver. Anyway, that's kind of it's a challenging market.
I think the market is still growing. It's just not at the kind of crazy rates it did during lockdown, for example. I think a number of business plans were written around, oh, surely we'll grow by 40% a year forever. But those business plans tend not to just live that long.
And I think AI, to kind of respond to what you talked about, I think it's going to be interesting to see where that, does it make sense to have VVC chips in every device when an NPU is already in a lot of devices and has general functionality? So at some point, we're going to see the end of codec-specific decode chipsets and probably encode as well. And that's where I think AI plays a potentially big role. The other thing is, I saw something the other day on the internet, so it must be true, but it talked about 50% of all video is for machines these days. And really, traditional codec was developed for you and me, for our human eyes. And it would be shocking if you couldn't do something much more efficient for the needs of autonomous driving or any other AI-based vision application with an AI codec that a current codec might not be suitable for. So I think those kind of closed applications where you can control both the encoder and the decoder is where we're going to see AI first.
Makes sense. Good stuff. We are coming to the end of the hour here. Jan and Adrian, thanks so much for taking the time to both present some things of value, but also to discuss some topics that the audience is interested in and that we are interested in. And speaking of audience, I said we were going to give away a $50 Amazon gift card, and we are randomly chosen attendee, Luke Wu. You're the winner of the Amazon gift card. You'll get an email in the next day or two with that information. Thanks again for joining us today. This webinar will be available on demand on the Norsk website sometime early next week. And there are more of these to come. Thanks so much, everyone.
Thank you. Take care all.